The reduced form model is a way of representing a system of simultaneous equations in econometrics by expressing each endogenous variable solely as a function of the predetermined variables, which include exogenous variables and lagged endogenous variables, and the error terms. In essence, you solve the system of structural equations for each endogenous variable. To understand the reduced form, it's helpful to contrast it with the structural form model. Structural form model represents the underlying economic relationships or theory. Each equation in the system aims to model a specific behavioral, technological, or institutional relationship, includes both endogenous and exogenous variables, as well as error terms that represent unobserved factors. The coefficients in the structural form often have direct economic interpretations, e.g., marginal propensity to consume, price elasticity. Example, supply and demand. Demand. $Q _t equals alpha _ 0 plus alpha _ 1 P _t plus alpha _ 2y _ t plus epsilon _ dt. Supply. $Q _t equals beta _ 0 plus beta _ 1 P _t plus beta _ 2w _ t plus epsilon _ cent $, where $Q _t quantity and $P _t price are endogenous. $Y _t income and $W _t wage are exogenous. $epsilon _dt and $epsilon cent are error terms. Reduced form model. Derived algebraically from the structural form by solving for each endogenous variable in terms of the exogenous variables and error terms. Each equation has one endogenous variable on the left-hand side and only predetermined variables and a composite error term on the right-hand side. The coefficients in the reduced form are typically combinations of the structural parameters and may not have a direct, straightforward economic interpretation. Example, reduced form of the supply and demand model above. Solving for $P _ t. Solving for $Q _ t. Where the $pi coefficients are functions of the $alpha and $beta coefficients from the structural form, and $v _ 1t and $v _ 2t are composite error terms involving $epsilon _dt and $epsilon cent. Key characteristics and uses of reduced form models. Forecasting. Reduced form models are often used for forecasting future values of endogenous variables because they directly relate the endogenous variables to predetermined variables whose future values might be easier to predict. Estimating the impact of exogenous variables, they can directly show the total effect, both direct and indirect through the system, of a change in an exogenous variable on each endogenous variable. Simplicity in estimation. Each equation in the reduced form has a single endogenous variable on the left, making it possible to estimate the equations using single equation methods like ordinary least squares, OLS, provided the error terms satisfy the necessary assumptions. Dealing with endogeneity. By expressing endogenous variables in terms of exogenous variables, the issue of correlation between the regressors and the error term, which plagues the structural form estimation with OLS, is often avoided. Identification. The reduced form is crucial in addressing the identification problem in simultaneous equation models. Identification refers to whether it's possible to uniquely estimate the structural parameters from the estimated reduced form coefficients. If a structural equation is not identified, it's impossible to recover its underlying parameters, even if we have consistent estimates of the reduced form. Limitations of reduced form models. Loss of structural information. The direct economic interpretation of the coefficients is lost. We can only see the overall impact of exogenous variables, not the specific channels through which these effects operate, as described by the structural equations. Policy analysis. Reduced form models can be less useful for policy analysis that involves changing the underlying structure of the economy, e.g., a new behavioral rule or a change in an institution. Since the reduced form coefficients are derived from the structural parameters, a change in the underlying structure can lead to changes in these parameters, and thus in the reduced form coefficients themselves. This is related to the Lucas critique. Understanding mechanisms. Reduced form models do not explain the why behind the relationships. They focus on the what, the statistical relationship between variables, without delving into the underlying economic mechanisms. In summary, the reduced form model is a valuable tool in econometrics for forecasting and assessing the overall impact of exogenous variables on endogenous variables. However, it sacrifices the direct interpretability of structural parameters and may not be ideal for in-depth policy analysis or understanding the fundamental economic mechanisms at play. The choice between using a structural form model and a reduced form model often depends on the specific research question and the goals of the analysis.